particle is projected vertically upwards with a speed of 7 meters per second from a point on the ground. Find the speed of the particle and its distance above the ground 0.4 seconds after projection. Find the total distance travelled by the particle in the first 0.9 seconds after projection. Okay, so let's have a look at this then. I've got the question summarised here. It's fired off the ground at t equals 0 with a speed of 7 meters. Find its velocity, or the speed of the particle, when t is 0.4 and its distance above the ground. Okay, so we've got v equals u plus at, haven't we? So let's have a look at that one then. This velocity will equal the initial velocity. So this gives the velocity is equal to the initial velocity, which is 7, plus the acceleration, which is minus g, times the time, which we know is 0.4. So v, the velocity then at 0.4, 7 minus 9.8 times 0.4 is 3.08 meters per second. So there's our velocity then. Now we want to find the distance above, so we can use v squared equals u squared plus 2as, can't we? And this formula gives, well, we know it's 3.08. Or we could use the formula S. S is equal to ut plus half at squared. So I think we'll use this one. So let's just use this second one, because it gives an explicit form here. So this one gives then S is equal to ut, so the initial speed was 7, the time is 0.4, and then half a is minus 9.8 over 2, so it's minus a half times g, 9.8, times t squared, which is 0.4 squared. So what does that equal then? Well, 7 times 0.4 minus 0.5 is half times 9.8 times 0.4 squared equals 2.016, which is equal to 2.02 to 3 significant figures. And this is meters. Okay, so there's our height here. Now part 2, find the total distance travelled in the first 0.9 seconds. Well, we need to find the time where it reaches the top to check whether 0.9 is, whether it's going to be on this side or on that side. So let's find the highest point then. So part 2, here, v, okay, we need to find the time up to the halfway, so v equals u plus at gives, so the velocity at the top is 0, the initial velocity is 7, a is minus 9.8 times time. That gives us the time is, move this over, it's 7 on the other side, and then move the 9.8 underneath. 7 divided by 9.8 equals 0.7142 seconds. Now that's the time of flight. Now 0.9 is past its highest point, so Okay, so we know, so we'll need to work out the highest point then, won't we? So v squared equals u squared then plus 2as gives. So what's the highest height then? So v is naught is equal to u squared, which is 7 squared. A is minus g, so it's minus 2g times s. So that tells us that 2gs is equal to the 7 squared. We just move this over there, which is 49. And s is equal to 49. Move the 2g from times to divide. So the total s that particle travels up is 49 over 2g. So we'll leave that in that form at the moment then. So that's the greatest height. So if we work out the height after 0.9 seconds, also t equals 0.9 gives s is equal to ut. S equals ut plus half at squared we're using here is 7 times the time, 0.9, plus half a is 9.8, half of that is 4.9, so it's minus half of this, 9.8 is 4.9 with a minus, times t squared, which is 0.9 squared. So this s, the displacement then, is 7 times 0.9 minus 4.9 times 0.9 squared equals 2.331. So there's the displacement. So basically the particle goes up. It goes up to its highest point and then it turns and comes back down. This height here is 2.331 when t equals 0.9. But here, the height here, which we worked out before, was equal to 49 over 2g. So total distance travelled then, which is the answer, when it gets to 0.9, is equal to 49 over 2g. It goes up, and we'll add another 49 over 2g. So we've done an up and a down then, and then take away this 2.331, 2.331, which equals 49 over g minus 2.331. Okay, so 49 divided by 9.8 equals 5 minus 2.331 is 2.669. And to three significant figures, that's 2.67 to three significant figures.